Yeah, so hi everyone, good afternoon and welcome to today's class. Uh, Hopefully you can see the screen. I think, yeah, it's visible. So before we move further, the first thing that we'll do is so these are the exercise questions that I've given you for module 1 that we discussed yesterday. So first we'll go through all the exercise questions and how to solve them. And then we'll go into the details of what entails module 2 and what we'll be learning in that. So basically there are, I think, 10 questions. We'll just go through them one by one. So the first question is assign an appropriate string to the variable, then print it. Okay, so we know the first man on the moon is Neil Armstrong. So we'll just write his name here in single quotes, double quotes, or whatever. Then in print, we print this variable that where we are storing his name. So yeah. Uh, then yeah, the second question is using the length function, find the length of your first name. So my first name is Arpit. Length would be length of first name, and then we just print length, just 5. For the next question, what we need is the sum of the first 5 positive integers. We can directly just add all 5 of them here and then print the answer, which is 15. Then the next question is to find the average of the ages of these 3 people. So average age in this case would be sum of all their ages divided by 3 because there are 3 people. So basically what we do is Sarah plus Mar plus Fatima divided by 3. The average age in this case is 24.33, which is very logical. Yeah. Okay. Find the number of times 73 goes into 403. So that means the number of times that we can take away 73 from or subtract 73 from 403. So basically we need to do a float division of 403 divided by 73. Answer turns out to be 5. And to find the remainder, as I mentioned in the class before, it's just a percentage sign. Exactly. Okay. You are given 2 variables. A, float, divide the 2 variables and print the result. Okay, the variables are integers. And the second point, convert the variables to float, divide them and print the result. Okay, so first we just need to float divide them. So x divided by y. Then we need to convert it to float, which can be done like this. So basically here we are converting both x and y to float and then dividing them. So the answer in this case is basically the same thing, but if we divide an integer by an integer, the answer will also be an integer. Whereas if we divide a float with a float or an integer, the answer will be a float. Yeah. So now we have a list. We need to print the first and the last items in the given list. So the first word would be words 0, because 0 is where the indexing starts. And when we are extracting words from strings or from lists or other data structures, what we do is basically we use indexing. So we put a square bracket and then we put some index. The last word, as I had mentioned in the class before, we can just use -1 to get the last thing of any list or string or word. That's basically going to be the last index. So we have bat and badminton. Okay, the next question is subjects were given an exam and the mark for a single student are provided to you. Oh, students were given an exam. Sorry, yeah. All subjects have a maximum mark of 20. Create a new dictionary for each subject and replace the marks with percentage of marks. Since all subjects have a maximum mark of 20, So the percentage of marks that someone scores is basically the marks scored divided by 20 into 100. So if we just, for example, in the case of math, it will be 15 divided by 20 into 100. Okay, so if we just, because in anyways, in all the cases, we have to multiply by 100 and then divide by 20 because all subjects have a maximum mark of 20. What we can basically do is multiply the marks that they got with 100 by 20, which is 5. So basically 15 into 5 would be the percentage. So we can do that easily by maths equals, sorry, colon marks dict maths into 5. Biology is marks dict biology into 5. Physics is marks dict physics and then into 5. Yeah, so now we have 75%, 90% and 80%, which is correct. Okay, given the two sets below, find their symmetric difference using operations such as union, intersection, and difference. Symmetric difference of two sets is basically a set containing all the elements that are exactly present in one of those sets. Okay, so what we can do is we can take the difference of A minus B. So this will give us uh, all the elements that are exactly present in A but not B. And to this, we need the we need to take this and the union of the opposite thing. So all the things that are in B but not in A. Basically, we do B minus A. That should do the case. 2, 3, 4, 5. So yeah, 2, 3 are there in A and 4, 5 are there in B. A set containing all the elements that are exactly present in one of these sets. Okay, that's it for module 1. Hope you all were able to solve these questions. These have been very simple enough because yeah, we just discussed very simple things. So yeah, after this we'll move on to the next module. Sorry. So if anyone has any like, can just check. There's one person. Okay. If anyone has any doubts or something, you can easily ask them. You can either use the chat box or unmute and start talking. Everything is welcome. So yeah, uh, so for module 2 today, what we'll be discussing is basically controlling the flow of execution. Okay, so basically things that a program that you write and provide to Python or to a computer is basically a set of instructions. So a program or an interpreter of a programming language goes through each of the sequences, each of the length of lines one by one, and then executes them. So sometimes what we might need is to some based on some conditions, skip some blocks of code or some parts of the code, or based on some other conditions, we need to add something more, or we need to modify something based on some condition, or sometimes we might need to execute the same thing again and again with different variables or the same variable increase. Like for example, if you want to sum, let's say 10 consecutive numbers. So then basically we have to perform the same thing, which is addition over and over again with a sequence of numbers. So things like that, basically we are repeating stuff. So we should also be able to tell the programming language that this is a part of the code that needs to be repeated these many number of times. So basically, that's all about control flow that we'll be learning today. So control flow is like broadly can be categorized into two types, which is conditional execution and repetitive execution. So conditional execution is basically things like if statements. So for example, let's say uh, if the value of some person's height is greater than this, then let them go on this ride on a amusement park or something. And if their height is less than this, then don't let them go. Things like that. That's conditional execution. So based on a condition, some parts of the code might or might not be executed. Loops are basically loops help us to execute the same piece of code again and again. So basically, if you want to print something a bunch of times, or if you want to add a single number or square something a bunch of times, or like do some operation on some data a bunch of times, we can basically write a loop for the same. Uh, After control flow, we will take a look at functions. So functions are basically abstractions that like help us reuse code and not write too much code. So basically, what functions do is they help us demarcate a block of code as something that we will use later, and thus functions are things that we can use define some place earlier and then use later how many ever times we want, or we can like some functions will have different parameters or values that they take, and like for example a function might be to add two numbers. So it basically takes two values and gives us the sum of those two values. So things like that. So uh, we can either perform an operation on something, or we can uh, run so the same code with different data or like different numbers or something like that. What functions basically do is to help us to keep our code clean and help us to increase code reuse, and like so that the whole thing looks very neat and we don't have to write the same code again and again, which might also lead to more number of errors if the same block of code is repeated here and there. Every time if you find an error, you'll have to modify it everywhere. So functions take care of that. So anyways, we'll first dive into control flow. Uh, yeah. Before that, if anyone has any questions, please let me know. I'll just drink a little bit of more water. Okay. Uh, so, uh, as I was telling you, by default, statements that you provide to Python are executed sequentially from the top of your file to the bottom, from the first line to the last line. Uh, so this can be altered in two ways, which is conditional execution or repetitive execution. So first we'll look at conditional execution. So basically the thing that helps us do the conditional execution is called an if condition. In many other programming languages such as Java and all, they also have if conditions, if and if else and stuff like that. So we'll be discussing that. So in Python, what we do is, so let's say we are defining a variable a is equal to 3. Then we want to print the variable. So this variable value that we are defining 3, we can change the value anytime. But anytime we change the value, we just want the value to be printed. If the value is positive, we want our program to print that a is a positive number. So what we put here is a if statement. So basically you write if and then you give a condition. So a condition is basically a statement which should return a boolean, a true or a false. So here the condition we are giving is if a is greater than 0. So if our number a is greater than 0, this condition will calculate to evaluate to true. And in that case, we put a colon here and then we put some space here and write the piece of code. We print that a is a positive number. Now, if a were to be a negative number, note that this will not print. So we'll try out both of them. So first we'll try out this a is equal to 3. It's printing it. Great. Now we put a is equal to -1. You see, it's not printing it because the value of a is -1 and the condition equates to false. And if the condition equates to false, the code here will not be executed. So, yeah. So what if we want both the cases? We want to print if a is a positive number or if a is a negative number. So in that case, what we'll do is, again, we'll write if a is greater than 0, colon, and we press. So since we're working with VS Code and most IDEs generally have this feature, where if you just put a colon and press enter in Python, it will align you to a like next indentation. So basically, that's how we demarcate code blocks for different statements such as if, else, and all. So every time you put a colon, you need to have a indent there. So yeah, so if this condition is met, print a is a positive number, else colon, print a is a negative number. Note that when we are putting this statement else, we don't need to put any conditions. Else will always take the opposite condition of what you put in if. So if a is greater than 0 means here else will happen only when a is less than 0. So as we see here, the a value that we have set here, let's set it to 3 first. It prints a is a positive number. Now again, if you set the value to -1, it prints a is a negative number. So sometimes we might have to make a decision based on multiple conditions. For example, if you are like throwing a die, you might have to check if the number is 1 or 2 or 3 or whatever, uh, 1 to 6. So in that case, we'll have multiple conditions to check. We can't just check one. So in this case, what we'll do here is we'll use something called elif. So elif is basically a short notation for else if. So basically, it's a else statement for an if statement, but it gives you the power to add another condition here. So for example, here we say if a is greater than 0, colon, then print a is a positive number. L if, else if a is less than 0, print a is a positive negative number. Else, print a is 0. So this third case will only happen when both of these statements are false. For whatever cases, if both all of the else and if and elif statements are false, then only the else block will be executed. For example, here again, if you try with 3, it prints a is a positive number. If you try with whatever negative number, it should print that it is a negative number. But if we try again with 0, it should print that a is 0. Is that clear? Great. So, yeah. One thing to remember is that as we were talking about nested lists and nested data structures, we can also have nested conditions. So every time you nest a condition, you increase the indentation value. For example, here we have a lot of conditions to say something specific about a number. So here we are defining a variable a. Then we are checking if a is greater than 0, then so basically, if A is positive, we add another condition here. If A reminder 2 is equal to 0. So if A is divisible by 2, print A is positive and an even integer. Else, print A is a positive number. So here, the first if statement will execute if a number is positive. Then the nested if statement will decide whether the number is an even number or not. So if this condition is satisfied that the remainder is 0 when divided by 2, we'll print that a is a positive and an even integer. However, if this condition is not satisfied, we'll just print that a is a positive number and not an even integer. Now we have a elif. Note here that the indentation here makes us realize what if, elif, and else blocks go together. For example, this if and this else are on the second indent, so that's why they are like going together because they are at the same indentation level. However, these three, if, elif, and else, are at the same indentation level, and that's why they three will be considered and executed as three connected if statements, if elif and else statements. So basically here we are testing if it's positive, we'll print these things. If it's not, if it's not positive but it's zero, we'll print a is zero. Else we'll print a is a negative number. Let's try out with some values. If we print -1, it says a is a negative number. For zero, it should say a is zero. For 5, it should say is a positive number. And if we put 6, which is even and positive, it says a is a positive and even integer. Is that clear? Great. So, yeah. Uh, so basically, the thing that we wrote earlier, we use two nested statements. So nested statements, what they do is they increase the complexity of the code in a way that uh, even computationally they are slightly heavy, I think. I'm not sure, I'll have to check that. But it also makes it difficult to read or understand some parts of the code. It makes it very congested kind of. So we can use operators to add a few conditions or like have multiple conditions in a given if. So for example, here we can see we can shorten the basically the thing that we wrote here with two like one nested if statement. We can shorten that to just one if statement by saying if a is greater than 0 and a is divisible by 2, that is the remainder of a when divided by 2 is 0, print a is even and positive. And if a is greater than 0 and a is not, the remainder of a divided by 2 is not equal to 0. So this is for not equal to. You put an exclamation and a equal to say that these things should not be equal. Then you put an elif to check if it's 0 and if it's negative. And again, if we do basically the same things over and over again, if we put 5, we'll get a positive. If you put 0, we get 0. If you put a negative thing, we'll get a negative thing. And if we put a positive even integer, we get a even and positive integer. Okay. So, yeah. Here we use the and statement to combine these two conditions. We can also use the or the not operators to carry out these conditional executions. For example, in this case, this if statement, this if statement will execute if the user is admin or if the access level is greater than equal to 4. So here in this case, since our user is not admin and the access level is less than 4, it should say access denied. In this case, yeah, however, if you change this to 4, it should say access granted. It does not need to match both, it just needs to match one. Okay, in the second case, we are using not. So if user is not admin, if not user is admin. So before whatever you want the negative of, you put a not. If not user is equal to admin, if user is not equal to admin, access is denied, else access is granted. So now our user is Jim, so he should be denied access as he is not an admin. Okay. So yeah. So this is something that people do a lot when they're using like they're writing web apps or something like that. So something that deals with web, where you get a lot of HTTP status requests and stuff. So basically, these requests tell you what the problem is there in the client side or the server side or things like that. So basically, sometimes when you're writing code, you have to treat these different status codes differently and print out things differently. So basically, here we are using a lot of if-elif statements to check if the code that we have matches a given thing, and then print out the most appropriate reason for that is HTTP status code. So we have if the status code is 400, print that it's a bad request. If it's 404, print that it's not found. If it's 418, print that I'm a teapot. Otherwise, print that something is wrong with the internet. So this else will capture anything that is not 418, 404, or 400. So now if you print this out. If we execute this code block, since our status is 500, we get that something is wrong with the internet. However, writing this if-elif is kind of uh, again cluttering. So what we can do is we can use what is called a match statement. So match statement is another statement that helps us do conditional execution. So basically, the syntax is this. Syntax is basically the way of writing. So you write match space what you want to match the variable colon. Then you go down and for each case that you wanted to match, for example, case 400 will occur when will be executed whatever the code you write here in case 400. This part will be executed if the HTTP status is equal to 400. So if it's 400, it should print bad request. If it's 404, it should print not found, and so on. This case underscore will catch rest of the cases that are not present here. So whatever else apart from that. So for example, if we have 500 here, it should say something is wrong with the internet. But if we change it to 404, it should say not found. Yeah, the last block variable name underscore acts as a wildcard, and it never fails to match anything. So that, yeah, whatever uh, is left out apart from these three, these thing will print this thing out. Yeah. So the next thing that we look at is repetitive execution. I hope everyone is understanding it till now, the conditional execution part. So basically, we use a if statement or a match statement to check if a condition is true or not, or if some variable value is matching to some other variable, some other value, and then we see, then we execute certain pieces of codes based on whether it is matching or not matching it. Is that clear? Great. So basically, a repetitive execution can help us repeat a certain block of code multiple times, altering the sequential flow of execution in Python. Mm, So Python provides us with loops that help us repeatedly execute a given block of code. There are two types of loops in Python. One is called a while loop and one is called a for loop. The while loop is used to execute a block of statements until a given condition is satisfied. When the condition becomes false, the lines of code after the loop will be continued to be executed. Okay. So for example, here we start with a variable count equal to 0. While count is less than 5, print count and count equal to count plus 1. So basically what we are doing here is increasing the value of count by taking the value of count and adding 1 to it. So every step, once this while loop has started, so again, while we have a condition here which returns a boolean, then we have a colon, and after that indented, we have the code to run if this condition is true, when this condition is true. So while this condition is met, this piece of code will be executed. Once this condition becomes false, this piece of code stops to work. So if we run this, it should print 0, 1, 2, 3, 4. Because after 4, so let's say in the first run, what happens? Count is 0. So we check here while count is less than 5. So is count is 0 less than 5? Yes, it is. So print 0. We printed 0. Then count equal to count plus 1. So the value of count now is 0 plus 1, which is 1. Now we again check, is count less than 5? Is 1 less than 5? Yes. So print count, print 1. Then count equal to count plus 1. So basically now count is 2. 2 is less than 5, so print 2. Then 2 plus 1, count becomes 3. 3 is less than 5, print 3. 3 plus 1, count becomes 4. 4 is less than 5, print 4. Print 4. Then 4 becomes 4 plus 1, 5. Now count is not less than 5, is equal to, it is equal to 5. Thus, this piece of code is not executed anymore. So we don't get a print 5. However, if we were to increase this to 6, we would again get 0, 1, 2, 3, 4, 5, 6. Okay. So one piece of advice is that always make sure that if you are writing a while loop, to add this last statement where you are increasing the value of the variable. So let's say I forgot to add this statement now. Okay. Now all I have is while count is less than 6, print count. All I have is this verse that I have highlighted. Count is 0, while count is less than 6, print count. So what will happen? So in the first trial, the Python interpreter will see that 0 is less than 6, it will print 0. Then again it will go here, it will see the 0 is less than 6, so it will print 0. Again it will go here and it will keep on repeating till infinity. It will not stop, it will basically break your code and like you won't be able to halt the program. So that's what happens when you run a while loop without making these increment or checking the variable, changing the variable that you are putting here. If I again like write count is equal to count minus 1, since I have this less than relationship here. So again, if from 0 I do minus 1, I get a minus 1, minus 2, and so on. I just get negative numbers. However, this will always execute to true in that case because 0 and any negative number will be less than 6. Thus, this infinite loop will again continue. To make sure that what sign you are putting here and what condition you are using here. Make sure that they both are aligned. Okay. Uh, uh, like we did with the if conditions, we can use the else statement in loops as well. So for example, here we write while count is less than 5, print count, else print goal reached. So what will happen here is the value will be initiated by 0. Okay. Then it will come, it will check 0 is less than 5, will print count. Then here basically what we are doing is count plus equal to 1. We are increasing the value of count. This is the same as count is equal to count plus 1. Okay. So it will add 1. It will again check since count is still 1 and which is less than 5, it will print it. It will be again be 2. It will check 2 is less than 5, it will print 2. It will check 3. It will count will evaluate to 3. 3 is less than 5. It will print 3. 3 plus 1, 4. 4 is less than 5. Print. 4 plus 1, 5. 5 is not less than 5. So now this condition turns out to be false. So this thing will be executed. But remember that this part of the code will be executed just once. Only once we'll write goal reach. This part of the code will be executed as long as this condition is met. Is that clear? Great. So next we'll learn about the for loop. So the for loop is basically the loop that you might be using the most in your day-to-day life and in course of doing data science in Python. So the for loop uh, is basically used for iterating over a sequence that is list, string, tuple, dictionary, or set. So let's say we have a list here, list of numbers 0 to 6. So what we write is for number in numbers, print number. So basically for each number that is present in the list numbers, the number is basically a variable that we are assigning. And in each iteration of the loop, the value of the variable changes from 0 to 1 to 3 to and so on. It takes the values that are present in the list numbers. So basically, if we do this, we'll print out all the contents of the list, 0 to 6. So first, for number in numbers, the value of number will be 0. We'll print 0. Next, the value will be 1, then 2, 3, 4, and so on. It will print all the numbers. Okay. So the above case, in this case, the variable number is the temporary variable that is valid only inside the for loop. So anything you write here involving number will work. We can similarly iterate over other sequence objects such as strings. So now we have a string called language is equal to Python. So for letter in this language, so for letter in this word, PYTHON, print letter. It should print the letters. Here, what we are doing is we are using a function called range. Okay, so I'll just separate these two. Okay, so this part we learned. This, if we run, it should come PYTHON. So now here what we are doing is for I in range length language. So basically here from this function, we'll get the length of the string language, which should be PYTHON 6. For I in range, so for I in range 6, print language I. So basically this will print the same thing. And because here we are getting the index values. For I in range 6 gives us the values from 0 to 6 by increasing 1. So 0, 1, 2, 3, 4, 5, 6. So now we are subset using those 0, 1, 2, 3, 4 as indices to get out the letters from the word. Okay. So as mentioned above, we'll take a small detour to talk about range, the range function. I think it needs to be talked about in greater detail because that is something you'll be using in your day-to-day life for data science. It will make your life simpler. So basically, for range, the thing is that the range method will create a iterable object from a given number to another number. For example, range. So this object is an iterable object starting from 0 to 10. So it has all the values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we use a for loop on it, it just spits out those values one by one. So 0, 1, 2, 3, 4 till 9. Because, yeah, again, like we had with the indexing thing, the start will be from the start. Here we have not mentioned the start, so it's taken as 0. Generally, if you mention one value, that's taken as the end value. If you mention 2, it's the start and the end. And if you mention 3, you can also get steps. Okay. So now for I in A, so for I in the range 0, 1, 2, 3, print I. So basically, it's printing from 0 to 9. It excludes the last number, the stop value. So basically, the range function takes these three values, start, stop, and stop. So here, range 2, 15, 2. So it will start from 2. It will go till 15 minus 1, which is 14. It will go in steps of 2. So all the even numbers, 2, 4, 6, 8, and so on. Now if we print this, we get 2, 4, 6, 8 till 14. Okay. Now we'll take a second detour to talk about something the else that we can use in a for loop to get like items from other types of objects. So for example, here uh, other types of objects, even sequences only. So for example, here we have a list called list1 is equal to eat, pray, love. Then we write for index comma item in enumerate list1. Print index comma item. So basically enumerate list1. Okay, we need to define list1 first. Yeah. So enumerate is an enumerator function. It basically gives you tuples of the index and the word at that given index. Sorry. For example, if we so now we are unpacking it into two items. So the enumerate in each step will give us the index comma the item. So we are opening it as index comma item. Then we just print the index comma item. So here in the first case, for index item in enumerate list1, what happens is it gives us the value 0, eat. Index will be 0, item will be eat. So we print it 0, eat. In the second time the for loop runs, it becomes 1, pray, 1, pray, then 2, love, 2, love, and it prints. Okay. So this method is very uh, yeah, useful if you want to iterate over a sequence object or something like a list, but you also want to get the index values of the list because you want to do some operation based on the index value. So that is also sometimes necessary. Okay, so now we end the detour. So yeah, uh, yeah. So we can use for loops to iterate over items in a dictionary. We can get both the keys and the key value pairs at the same time. For example, here we have a huge ass dictionary that we have made with details of one person. Okay, such as the age, first name, last name, country, if they're married, skills, and the address and stuff like that. For key in person, so person is the name of this dictionary. If you use the for, um, one second. So first, let's just define this dictionary. Now we just print out for key in person, print key. So basically, it will just go over all the keys that are present directly in the dictionary person. So the keys are first name, last name, age, country, is married, skill, and address. Note that address is itself a dictionary, but the key here is address, and that is the key that will be there in the first dictionary person that we created. So now, if when we are doing this for statement for key in person, we are basically, if we just directly use the name of the dictionary, we are basically iterating over the keys that are present in the dictionary. However, if you want to iterate over both the keys and the values, we can write for key comma value in person dot items. Remember, person dot items is something that we learned about when we are learning about dictionary. So basically, person dot items is a iterator that gives us the key and the value pairs, each key and value pairs one by one. Basically, this will print out each key and value pairs one by one. First name is this, last name is this, age, country, and stuff like that. Cool. Yeah. So earlier I had mentioned when we were learning about sets that we cannot get a individual item from a set using the index. For example, writing the name of the set, uh, for example, writing the name of the set and using a square bracket and using an index. We cannot do this. This will fail for a set. However, if we use a for loop, we can iterate over the values that are there in a set without ever accessing them via their index. So for company in IT companies, it's basically not going through any index. It's just picking out values random, like values from this set. If we print this, it will print out all the values that are stored in the set by once. But again, it does so randomly, I think, because it's a set. Hmm. So here, what we are doing again is using the range function to get from 0 to the length of the IT companies. And then what we are trying to do is we are trying to get the value of, get the different values using indexing at the given index. So this is not supposed to work because that does not allow us indexing. Okay. Huh. So basically now we learn about something called tuple unpacking. Okay. So basically, let's say we have a list of tuples here. So for tuple in this to print tuple, this should print all the tuples that are there inside the list because each tuple is an item of a list because there are commas here only outside that. So it should print 2, 4, 6, 8, and 10, 12, which it does. Now, what we do is for T1, comma T2 in list 2. So basically what we are doing is instead of tuple here, one variable, we are providing two variables for the for loop to get from the list. And we are just printing T1 out of those. So this should print only the first thing. Because now each tuple in list 1, that is 2, 4, 6, 8, and 10, 12, sorry, gets mapped into, for example, 2 gets mapped to T1, 4 gets mapped to T2, 6 get maps to T1 in the next round, 8 gets mapped to T2. In the next round, 10 will get mapped to T1 and 12 will get mapped to T2. Now, if I change this to print T2, should print out 4, 8, and 12. So as with if statements and while loops, we can use else and for loops also for number in range 11. So prints numbers from 0 to 10, then else it will stop. So else is basically when the range reaches 11, it should stop. Then we print the loop stops at dash. Yes, the loop stopped here at 10 only. Then the else thing was executed. But note again here, like the while loop, this part of the code is executed multiple times depending on whether it satisfies this condition or not. But once this condition is false, this part of the code is executed just once, and then the execution continues. The for loop is done, or the while loop is done. Okay. So the next thing that we need to learn about are break, continue, and pass. So basically, the for loop and the while loop have special keywords that can be used to modify the execution of the loop. The break statement, if we use, it will halt the execution of a loop totally. The continue statement, if we use, it will skip the current iteration and the loop continues to the next iteration. For example, it can be used to skip one particular value of the loop. Okay, so if we are iterating from 0 to 5, we can skip, let's say, 1 or 2 or 3. The pass statement basically does nothing. It's used when we want to have a, like, when we are forced to have a if statement, but there is, or a else statement, but there is no action that we want to take. So for example, here we have a loop. So count equal to 0, count is the variable. While count is less than 5, print count, then increase count. If count is equal to 3, break. So basically in the first step, what will happen? Count will be 0. So 0 is less than 5. So we'll print count. Then we'll increase the count value of count by 1. After that, we are checking if count is 3. It's not 3, it's 1. We don't break. So this break part of the code is not executed now. So 1 will again go to the while loop. 1 is less than 5. So we'll print 1. We'll increase the value of 1 to 2. 2 is not equal to 3. So this part does not execute again. We go to 2. 2 is less than 5. So we print 2. Then we do 2 plus 1 is equal to 3. The value of count is now 3. Now count value is 3. If count is equal to 3, this condition is satisfied. So this will be executed and the loop will be broken. So basically, he'll just print 0, 1, 2. We won't print 3 or anything after that, even if the while condition is still satisfied. Exactly, 0, 1, 2. Again, here, so this was an example using while loop. Here is an example using for loop. For number and numbers, we are printing a number. So basically, we are printing 0, 1, 2, 3, 4, 5, 6. If the number is 3, break. Break will basically stop the execution of this whole thing. Okay. So basically, we'll print 0, 1, 2. When it's 3, we'll print 3 because for number in numbers, number is 3 now. We print 3 and then we check if it's 3 and then we stop. So here we'll print 0, 1, 2, 3. Exactly, 0, 1, 2, 3. Then here we are using the word continue to skip one iteration. So basically, we are starting from 0. We are checking if the variable is less than 5. If the variable is 3, then we are just increasing the variable and we are continuing. If it is not 3, so basically, if it is 3, this will be executed, otherwise not. If it is not 3, this will be executed, otherwise not. This part will be executed irrespective of what the condition, if here is satisfied or not. So basically, again, we'll print and we'll increase the value of count. So we'll start at 0. Sorry. We'll start at 0. 0 is less than 5. So we'll continue with the while loop. If count is equal to 3, so 0 is not equal to 3. So this part will not work. Then next we'll print count 0. Count is equal to count plus 1. It will be 1. 1 is less than 5. 1 is not equal to 3. So we'll print 1. Then it will be 2. 2 is less than 5. 2 is not equal to 3. We'll print 2. Then it's 3. 3 is less than 5. Now here 3 is equal to 3. So we'll do this. So what this does basically is 3 plus 1, 3 is equal to 3 plus 1. 3 now becomes 4. So now we print 4. And then again we increase it to 5. Now this condition is not satisfied, so we don't print 5. So we just print 0, 1, 2. We skip 3 and we print 4. 0, 1, 2, 4. In this case, again, we are using the same thing, continue, but here using a for loop. For number in numbers, if the number is 3, continue. Otherwise, print number. Here, since we have numbers from 0 to 5, all 5 of them are printed. So, yeah. Basically, what this continue does is anything after this, if it's satisfied, is not executed, we come again from above. So in this case, if count is 3, we just increase count. Then we continue, we start with 4 here. And 4 is not equal to 3, so we print 4 and do this. Pass basically does nothing. So if you write this, nothing will happen. It's just a placeholder if we need some for loops based on syntax or some, because of some condition we are used to forced to use a for loop, but we don't want it to do anything for us. Okay. As with if conditions, we can also make nested for loops. So we can have for loops or while loops inside other for loops or while loops. So for example, here we have a dictionary, again the same dictionary we had before. For key in person, so we'll go through the keys in person. The keys are first name, last name, age, and so on. Then we'll go through them one by one. If key is equal to skills, so if the key is skills, if the key is this, for skill in person, index skills. So basically, for every skill that is present in this thing, in this value related to the key skills, print the skill. So we'll just print out these values, JavaScript, React, and Node, and so on, one by one, when we run this loop. So these are some of the reference materials that were used in making this document. So yeah. Next, so we'll talk about functions. So, but should we talk about functions now or in the next class? This class is supposed to be 1 hour. Anyways, so Fridays we are supposed to have class for 1 hour. So we'll just stop here with control flow. Basically, functions, which we'll learn about in the next class. Functions are blocks of code that run on only when they are called. They are like basic building blocks that we can use to construct larger pieces of codes and run them again and run them using different values or parameters. On a more fundamental level, functions help us to prevent repetition of code. And yeah, so basically we have used a lot of functions till now, such as the function print or the function len or something, other built-in functions. So basically these are functions that are declared or defined in the Python standard library, and we are just directly using those functions without having to write the code for them. So for example, when you are using something like uh, length of, so let's say we have this, we are a person, when we are writing length of person. So basically we are getting the length of person, which is 7. We're just counting these keys, but we don't have to explicitly write the code for that. The code is already written and stored somewhere. in some module in the standard library. We are basically just calling the function and it does the work for us. So instead of person, if we put anything else here, for example, if we have other things such as list one that we defined above, or some other sequence or something for which we need the length, we just put this and we get the length. So these are basically functions. These we'll talk about in the next class, coming Thursday. And then we'll have a session like, yeah, we'll talk about it coming Thursday and we'll have a exercise question, set of exercise questions for this module. And then if we have time, we'll move on to the third module. Okay, so that's it for today. Hope you had a great time and happy Republic Day to everyone. So I'll stop here and we'll meet again next class. Thank you.